Hello everyone. In this video I'm just going to work through all of the example problems from the study guide, so let's just get right to it. So the first problem here is just a straightforward finding the equilibrium in a market represented by a supply equation and a demand equation. So we start by setting these two equal to one another. We're imposing equilibrium. We're saying, all right, we want to see where these two equations are equal to each other, so that's why we can set them equal. So 30 minus p is equal to 3p minus 10. Alright, so let's start by getting 10 over here. Leaves us with 40 minus p is equal to 3p. Add p to both sides. Going up here. So that gives us 40 is equal to 4p. Divide both sides by 4. And that leaves us with p star is equal to 10. So now to get equilibrium quantity, we just have to plug that 10 back into either of the original equations. So let's do the top one. So Q is equal to 30 minus 10. So Q star is equal to 20. And so just to connect that with our graphical representation, if we've got our normal supply and demand diagram, let's say that, this is our supply curve, this is our demand curve. What we've done here is we've just found Q star is equal to 20 and P star is equal to 10. Alright, so moving on to the next question. This is the same idea, but instead of having equations, we have a table. So outright, we just want to find equilibrium in the market. So pretty straightforward. We just look where supply and demand are equal to one another. And here we see that that's at 100 and that the corresponding equilibrium price is $3. So Q star is equal to 100 and P star is equal to 3. So now the second part of the question is, suppose that at every price people are willing to consume 75 fewer units of the good in question, and then what would the new equilibrium price be? So to do that, to figure that out, um, we have to write out a new demand schedule, right? Because if people are willing to consume less, then that's a demand effect, right? So we'll call this D prime. And so what we need to do is just subtract 75 from each value that appears here. So 200 minus 75 is 125. 150 minus 75 is 75. 25. And then would be negative 25, but the demand curve won't go below 0. So we'll just set it to 0. And so we can see here that the new demand curve is equal to the supply curve at 75. So after the change in demand, we have a Q star of 75 and a P star of 2. And so once again, just to kind of connect this to our graphical representation, downward sloping demand curve, upward sloping supply curve, all that we saw going on here was a inward shift in the demand curve. So this would be D prime, and we just found the new lower equilibrium price and lower equilibrium quantity. And as compared to the original equilibrium, we can see that quantity has fallen, and so has price. All right, so moving on to question 3. At a price of $750, 300 bikes are sold. Suppose the price of bikes falls to $500 and demand increases to 330. What's the price elasticity of demand for bikes in this market? So let's figure out by figure this out by labeling what the initial price and the initial quantity is, and the new price and the new quantity. So the initial price is 750 and the initial quantity is 300. The new price is 500 and the new quantity is 330. So just to remind you, the equation for price elasticity demand is the absolute value of Q1 minus Q0 over Q0, and then P1 minus P0 all over P0. And this is kind of the expanded form of just the percentage change in Q over the percentage change in P. And we've got to have that in an absolute value because this is a price elasticity of demand. This is the only elasticity that we take the absolute value of. So let's work through this. So the elasticity is equal to Q1, 330, minus Q0, 300, all over 300. And that is over top of 500 minus 750 over 750. And once again, all in the absolute value. So just simplifying that, we end up with 30 over 300, which is the same thing as 1/10. And in the denominator, we've got negative 250 over 750, which is the same thing as negative 1/3. So if we go ahead and evaluate the absolute value, the negative sign in the denominator disappears. And to get a complete solution, we just take the numerator and multiply it by the reciprocal of the denominator. And so we get 3/10, or, in decimal form, 0.3. And so since this elasticity is equal to 0.3, which is less than 1, then we know that demand for bikes, in this market at least, is inelastic. So that means that people are, whenever the price changes by 1%, people change their consumption behavior by less than 1%. Let's move on to another elasticity question. So here's number 4. At an income level of $100,000, someone demands one house. At an increased income level of $250,000, this person demands 2 homes. What is the person's income elasticity of demand, and are homes a normal or inferior good? So since this is a elasticity of income elasticity, we cannot take the absolute value because the negative sign tells us whether the good is a normal good or an inferior good. And we use more or less the same formula as we did for a price elasticity of demand. It's just that the prices are changed out for incomes. So let's start by figuring out income 0, quantity 0, income 1, quantity 1. So we start at 100,000. The second income is 250,000. Quantity 0 is 1, and quantity, the second quantity is 2. So to go ahead and set that up in our formula, quantities always go in the numerator. So it's going to be 2 minus 1 over 1. The new value minus the old value over the old value. In the denominator, we've got 250,000 minus 100,000 over 100,000. All right. So simplifying that out, 2 minus 1 is 1, so we end up with just 1 over 1, which is the same thing as 1 in the numerator. In the denominator, we end up with 150,000 over 100,000. So simplifying the denominator, that's the same thing as 15 over 10, which is the same thing as 3/2. And 1 in the numerator. So since we've got 1 over a fraction, we can just take the reciprocal of the denominator. So we end up with 2/3, which is greater than 0, which implies that homes are a normal good. That is, that it's a good that you consume more of as your income increases. Okay, so next we have a labor market question. So consider the table below, assuming it represents a competitive labor market. We've got different wage rates that correspond to a labor demand and a labor supply. We want to figure out what the equilibrium employment and wage rate will be. So this is very similar to question 2. We've just kind of relabeled things in terms of a labor market rather than a product market. All right, so finding the initial equilibrium is the same exact process. We see labor supply and labor demand are equal to one another at 60, and the wage rate is 12. So we know that L star is equal to 60, and W star is equal to 12. The second part here says, suppose that 40 more units of labor are supplied at every wage rate. What will the new equilibrium employment and wage rate be? So just like before, we need to modify one of the curves, in this case the labor supply curve. So we add 40 to each value. So we get, let me change that to a darker marker. So 20 plus 60 is equal to, or sorry, 20 plus 40 is equal to 60. And so this will be like our new labor supply curve, S prime. 40 plus 40 is 80. 60 plus 40 is 100. And 80 plus 40 is 120. All right, so after that takes place, we just have to go look at our original labor demand curve, and we can see that they're equal to one another at 80. And the new wage rate is 11. So your new L star is 80, and your new wage rate is 11. So I always like taking this back to the graph. Whenever we've got a labor market, price becomes wage and quantity becomes labor. We still have our normal downward sloping demand curve, upward sloping supply curve. And here we have an outward shift in the supply curve, S prime. And just kind of charting out the changing values. With the new supply curve, we've got more labor supplied, and it's at a lower wage rate, which corresponds to what we found over here. And so using the graph is one way to double check that you're doing it right. Okay, so here we have a simple market, and all I'm asking you to do here is to find total surplus. So that's the sum of consumer and producer surplus. We can also just find the area of the total surplus triangle directly. So let's just find that all at once. So we'll take this as the base. So just remember the area is equal to 1/2 base times the height. So we'll do 1/2 the base, which is 10 minus 2, times the height, which is 75. And so 10 minus 2 is 8. So we get 8. We can go ahead and multiply that by the half to get 4 times 75. And so 4 times 75 is, I believe, 300. So that's the total surplus in this market. So now question 7 expands upon that. So we've got the same market, but instead let's assume that a price floor is put in place at $9. So the actual market outcome experienced is that point right there. So we want to figure out the size of the deadweight loss created by this price floor. So to do that, we're just finding the area of this triangle right here, because remember, that is deadweight loss. This upper triangle is consumer surplus, and this lower triangle here is, or this lower kind of squared triangle is producer surplus. All right, so to find the area of the deadweight loss, we just use the given information. So we can take that distance as the base and this distance is the height. So 1/2 base, which is 9 minus 4, times the height, which is 75 minus 50. So 9 minus 4 is 5, 75 minus 50 is 25, and then we have 1/2 here still. So 5 times 25 is 125, so we still have to take care of the half, and dividing that in half, we end up with 62.5. And so we know that the dead weight loss is 62.5, which means that there's 62.5 fewer dollars of consumer and producer surplus with the price floor in place than without it in place. Okay, so the next question is on trade. So we've got two production possibility frontiers here, one for country A and one for country B, and each country produces two goods, capital goods or consumer goods. And so we want to figure out each country's opportunity cost of producing capital goods and which country should specialize in producing capital goods. So remember that opportunity cost is what you give up. So we want to figure out how many consumer goods each country gives up for each capital good it produces. So in country A, if they devote their entire production to capital goods, if they devote their entire production to consumer goods will be in the numerator. They can produce 50. And if they devote their entire production to capital goods, they could produce 40. So that gives us 5/4 for country A. So that's their opportunity cost of producing capital goods. For every one capital good they produce, they give up 5/4 consumer goods. In country B, they can produce 150 consumer goods if they only produce consumer goods, and only 10 capital goods if they produce capital goods. And so here, that reduces down to 15. So it's a pretty stark difference here. We can see that country A's opportunity cost of producing capital goods is much lower, and as a result, they should specialize in the production of capital goods, and country B should specialize in the production of consumer goods. So the tricky part there is always remembering that it's the other good that goes in the numerator. All right. So the next question is about a monopolistic market. So we've got a graph here, and we want to figure out what the prices and quantities will be under both perfect competition and monopoly. So I'm going to start by highlighting the outcome under perfect competition, and that'll be in green. So I've intentionally left the curves unlabeled here because you kind of need to know what those are. So this curve that's upward sloping is the marginal cost curve, also the same thing as the supply curve. The two downward sloping curves are the demand curve and the marginal revenue curve. Because for the monopolist, the demand curve and the marginal revenue curve aren't the same thing. Marginal revenue lies below the demand curve. But if this market were perfectly competitive, the outcome would be where supply is equal to demand. So the outcome would be this point right here. So we would have P1 and Q0. Now, under monopoly, instead of setting quantity where supply is equal to demand, quantity will be set where marginal cost is equal to marginal revenue. So I'm going to do monopoly in red. And so quantity gets set where these two curves cross. Marginal cost and marginal revenue cross one another. And so one subtlety here, though, is that that point would seem to correspond with P2, right? But at this quantity, people are willing to pay this much higher price of P0. So that's actually the price that the monopolist would charge. So remember to always project up to the demand curve. So for the monopolist, we end up with Q1 and P0. And just to compare the outcomes, we can see that it is a higher price and a lower quantity, which is the expected difference in market outcome whenever we have a monopolist rather than a perfectly competitive producer. All right, so the next one here is a consumer problem. So we're trying to figure out what the optimal consumption bundle will be for this consumer. So I've already filled in all of these values that are highlighted here, but on the exam, you may not receive some or any of the highlighted figures. So we'll go through and calculate each one, or at least a couple of each one. So to find out the marginal utility of good A, the way we do that is we subtract subsequent cells in the total utility of good A. So to get 45, it's just 45 minus 0. To get 30, it's just 75 minus 40. And so on. So 15 comes from 90 minus 75. And then we would do the same exact thing for good B to find the marginal utility of good B. So what that tells us is how much utility the consumer gains from each unit of both goods B and goods A. But we have to divide that by price because the consumer faces different prices for good A and good B, right? So it doesn't matter that good A, first unit of good A makes the consumer happier than the first unit of good B if their prices, may change that or may differ a lot. So to fill in the marginal utility per dollar for both goods A and good B, we just divide the marginal utility by price. And so we're given that good A is $3 and good B is $2. So to find marginal utility per dollar of good A, we have to divide marginal utility of A by 3. So 45 divided by 3 is 15, 30 divided by 3 is 10, and so on. And then for good B, the price is $2. So we divide 24 by 2 to get 12, 16 by 2 to get 8, and so on. So now we have all of this information we need to figure out what the consumer's consumption bundle is going to be. Because we also have their income of $8. So income is equal to 8. So we just have to think through this sequentially and just buy the unit of which good gives us the highest marginal utility per dollar and deduct that from our income until we have no income left. So here, comparing the first unit of B to the first unit of A, we see that the first unit of A gives us more marginal utility per dollar, 15, and a unit of A costs 3, so 8 minus 3, which leaves us with 5. Next, we're comparing the second unit of A to the first unit of B. We can see that the first unit of B gives higher marginal utility per dollar of 12. So we'll buy that unit. B costs 2, leaving us $3. And so now we're comparing the second unit of A to the second unit of B. The second unit of A gives more marginal utility per dollar, so we'll buy that. A costs $3, leaving us with no income. So now we know that the optimal consumption bundle will be 2 units of A and 1 unit of B. We could also figure out what the total utility of the consumer would be having purchased this bundle by adding the total utility with 2 units of A to the total utility of 2 units of B, which here would just be 99. All right, so the next one here is a firm problem, and this one should be fairly straightforward. So suppose that a firm has fixed costs of $1,000, variable costs of $2,000, and the firm is currently making $1,500 in revenue. Should this firm shut down in the short run, and should it shut down or should it exit in the long run? Would be a better way of phrasing it. So in the short run, as long as the firm is making revenue greater than variable costs, they should operate. And the idea there is if they're covering their variable costs, then even if they're making a loss, then they are at least paying towards some of their fixed costs. So they're at least paying those down some. And if they just shut down in the short run, they've got to pay those fixed costs and they've got nothing they can put towards them. So right here we can see that variable costs are $2,000, but they're only making $1,500 in revenue. So because of that, this firm should shut down in the short run, and because they're making a loss, then they are definitely going to exit in the long run as well. So shut down in the short run and exit in the long run. And that's how all those questions go. Basically, in the short run, the criterion is the relationship between revenue and variable costs. In the long run, it's just are they profitable or not. All right. So number 13 here has to do with what we're going to be talking about on Monday, which is kind of formalizing the idea of externality. So in a market that has a negative externality, there are certain costs of the transaction that are not paid by either party who are involved in the transaction. And to represent that fact, we show a social marginal cost curve. And social marginal costs are inclusive of both externalized costs and the private marginal costs. So that's the normal marginal cost curve that's actually representative of the cost structure of the firm. So in the absence of any policy to change the market outcome, the market's only going to take into account private marginal costs. And so we'll get this same outcome as any other competitive market where supply is equal to demand, or here private marginal cost is equal to demand. So we end up with a price equal to B and a quantity equal to E. So if we instead introduce a Pigovian tax, so that is a tax intended to reflect the externalized costs of a particular transaction and to impose those on people involved in the transaction directly, we would essentially tax the supplier exactly enough to make the private marginal cost curve equal to the social marginal cost curve. And so instead of having a outcome where supply is equal to demand, we'll have an outcome where demand is equal to social marginal costs. And so under those circumstances, we end up with P is equal to A, and Q is equal to D. And this is the outcome we would want, because whenever there's a good that produces a large negative externality, that good ends up being overproduced and provided at too low a price. And a Pigovian tax would bring quantity and price more in alignment with the true costs of producing that good. Alright, so just a few more left. So number 14 here is a game theory question, right? So we've got two firms that are strategically related, so they're in an oligopolistic market, and they can choose to charge a high price or a low price. And so to figure out the strategic equilibrium of this game, or the Nash equilibrium, we have to use best response analysis. So let's start by assuming firm A chooses high price. Then the best response of firm B would be to choose low price, right? Because they would prefer a profit of 2 to a profit of 1. Assuming firm A chooses low price, then firm B would also choose low price because they'd prefer a profit of 1 to a profit of 0. Now we got to do the same thing for firm B. So assuming firm B chooses high price, firm A would prefer a profit of 3 to a profit of 1, so they choose low price. And assuming firm B chooses low price, firm A would prefer a profit of 2 to a profit of 1, so they choose high price. So here we've selected the two outcomes in this high price, low price. So the equilibrium outcome of the game would be firm A chooses high, and firm B chooses low. So this is an example of a game with an asymmetric payoff structure that results in an asymmetric strategy, right? One firm chooses high and the other chooses low. And in the real world, we could tell a story about like market segmentation here, right? Where there's one firm that targets like a high price market and one firm that targets a low price market. And kind of interesting in the way that this game is formulated, the strategic outcome of this game actually maximizes the total profits generated in this market. So if we add up the profits in this cell, it's larger than the profits in any other cell, which isn't necessarily going to be the case in every game. All right, so here we've got a table representing the cost structure of a perfectly competitive producer. I ask you to complete the marginal cost column. Suppose the price is $40. How much should this producer supply? So the important thing to know here is that for a perfectly competitive producer, price is equal to the demand curve, which is the same thing as the marginal revenue curve. If we draw that graphically, we've got Q, we've got P, we've got some upward sloping marginal cost curve, and then the demand curve, which is the same thing as marginal revenue. Ooh, ran out of room there. But the demand curve, which is the same thing as marginal revenue, is a horizontal line. So demand is perfectly elastic. All right, so let's start by figuring out the marginal costs. So just like always, we subtract subsequent cells. So here we do 120 minus 100 to get 20. So 120 minus 100. And then here 150 minus 120 to get 30. And so on. I've got those filled in here, so we can just do this directly. So suppose that price is 40, how much should the producer supply? So if price is 40, then we can see that the marginal revenue is going to be equal to marginal cost at 40. Total cost will be 190, and our output, our Q star, is going to be equal to 4, because that's the quantity that corresponds to those cells. All right, so the next one is about measuring market power. So I've got a market here with a number of firms with different market shares, and I want to figure out the 4-firm concentration ratio and the Herfindahl index. So the 4-firm concentration ratio is just the sum of the 4 largest shares. So they happen to be in order in this table, but they may not be on the exam. And so we can see the 4 largest are, firm A with 35, firm B with 25, and so on. So the 4-firm concentration ratio is equal to 0.35 plus 0.25 plus 0.15 plus 0.10. So simplifying that down, we get, what would that be, 50, 60, 70, 80, 85, so it'd be 0.85. So this market's really concentrated. So we've got a market where the 4 largest firms control 85% of the market share. So the Herfindahl index is a little more involved. So for the Herfindahl index, often abbreviated HHI, to figure out that, we just square each share and sum it up. So 0.35 squared plus 0.25 squared plus 0.15 squared, and so on. Plus 0.05 squared plus 0.05 squared, and then the last one, I think I'm going to run out of room here, plus 0.01 squared. And at this point, on the exam, just having that set up is sufficient. But if you've got a calculator and you evaluate this out, we round after rounding, we end up with 0.022 for the Herfindahl index. All right. So for the last one here, it's another welfare analysis question. So we've got a monopolist. And so with the monopolist, we're going to end up having producer surplus of B, consumer surplus of A, and deadweight loss of C. And all I'm asking you to do in this question is to figure out the deadweight loss due to monopoly. And so to do that, we just find the area of that triangle again. So 1/2. So 1/2 times 30 minus 10. That's this side of the triangle. Times 150 minus 100, which is that side. So simplifying that out, we end up with 20 times 1/2 times 50. 20 divided by 2 is just 10 times 50. And finally multiplying that out, we end up with a deadweight loss of 500. All right, so that's the last question from the study guide. I hope you find this video useful, and thanks. Bye.